Okay, so let's continue with this problem here. This is 339. This is the second half of it. We're going to find the change in the diameter. All right, so to do that, first we need to find the strain in A, use the Poisson ratio to get the diametric strain, and using that in the strain definition, change in diameter over the original diameter to get the change in diameter. So delta L. Well, we know that the change in length in A, that's the delta L, right? That is the reaction force, minus the reaction force in A times the original length of A over AE. All right, so I didn't explicitly get the reaction force before, but I can do that now. If you go back to the prior video, and we can get that from equation 1b, that'll give us that. That gives us that reaction A is equal to the 80 kilonewtons minus 26.7 kilonewtons meters times x, but we found out in the prior part that x is 1.53 meters, okay? So this will give me RA equal to 39 kilonewtons. Then obviously RB from sum of forces in the y is going to be 41 kilonewtons. Okay, since they both have to add up to 80. Okay. All right. So so we're good to go here. So delta A is equal to the 39 kilonewtons, okay, times its original length, which is 220 millimeters over AE, and we figured out AE before was 516.4 times 10 to the 6 newtons, or meganewtons, if you will. Okay, so the 10 to the minus third of the millimeters cancels out with the newtons, the kilo of the newtons, so that gives me now 39.22 times divided by 516.4 times 10 to the 9th. I'm sorry, 10 to the 6th, right? 10 to the 6th. And that gives me 1.66 times 10 to the minus 5. Now that's going to be meters, or in millimeters, that's 0.0166 millimeters, right? Because that's 1, 2, 3, 4, 5, 3, 2, 3, 4. Actually, it's another 0, right? Another 0. Excuse me, right? So that this is 10 to the minus first, second, third, fourth, fifth. Okay. All right. Now we know the elongation. That means I can get the strain in A. That's going to be 1.66 times 10 to the minus 5 meters over the original length, which is the 0.220 meters. And that is, well, actually I could have gotten it more directly just for doing force of air times Young's modulus. 0.225. So that gives me 7.55 times 10 to the minus 5th strain units. Okay? Millimeters per millimeter. All right, now we know that. I can get the diametric strain. this relationship, from the Poisson ratio relationship. So the diametric strain is minus 0.35. And actually, I lost the minus sign here, so this should be a minus, because it's in compression. So that's a minus 7.55 times 10 to the minus fifth. And that gives me 2.64 times 10 to the minus fifth. This is positive, so the diameter is getting bigger. And then using this relationship, I can get that the change in diameter is the strain, the diametric strain, times the original diameter, which they tell me is about 30 millimeters. And that gives me an increase of 7.9 times 10 to the fourth millimeters. So the diameter of support A increases by 7.9 times 10 to the minus fourth millimeters. Okay?